So remember that radioactive decay will transform atoms of an element by transforming the nucleus in some way. And remember that it's the number of protons that characterizes an element. It makes the element what it is. Radioactive decay can change the number of protons in the atom. When we talk about this transformation, there are three types of transformations that can occur. The first is alpha decay. With alpha decay, the nucleus emits an alpha particle. That means it gives off one of these alpha particles. When that happens, the nucleus loses things. It loses 2 protons, these 2, and it loses 2 neutrons, these 2 right here. So what happens then is that the atomic number of the element decreases by 2, and the mass number, the sum of neutrons and protons for that element, decreases by 4. Here's an example. Radium gives off an alpha particle to become radon. So here in this equation, we see radium and then arrow, that represents the decay, and then radon and an alpha, and the symbol for an alpha particle. And you can see that our mass number goes down by 4. It goes from 226 to 222. And our atomic number goes down by 2. It goes from 88 to 86. So our atomic number is now 86, and that's the element radon, not radium. So this atom has become a different element, and it will act differently. Excuse me. Radon is a noble gas. It's relatively unreactive. Radium will react with other elements. That's alpha decay. Another one is beta decay. Now what happens is that a neutron splits into a proton and an electron. The electron is given off as the beta particle, which of course has very little mass, as we've talked about. The proton remains in the nucleus. So with our numbers here, with beta decay, the atomic number increases by 1, because 1 neutron has now become a proton, so that number of protons goes up by 1. The mass number remains the same. We're not losing much mass by giving off the electron, and it's just that 1 neutron has now become a proton. So the mass number, we're not losing or gaining mass, so that remains the same. Here's an example. Boron gives off a beta particle to become carbon. Boron 12, that is, which is a radioactive isotope of boron. So notice the mass number is the same, 12 and 12. The atomic number goes up by 1, from 5 to 6, because one of these 12 particles went from being a neutron to a proton. So now, because the atomic number is 6, the atom acts as carbon and not boron. That's beta decay. Now, atoms can also capture radioactive particles, and that's beta capture. So this is the reverse of beta decay. A proton in the nucleus captures a beta particle, and it becomes a neutron. So the atomic number decreases by 1. Why? A proton has become a neutron, so we have 1 less proton, so the atomic number decreases by 1. Mass number remains the same. We have the same number of massive particles in the nucleus. It's just that one has switched teams, so to speak. It went from being a proton to a neutron. So here, mass number is the same. Potassium 40 captures a beta particle, and it becomes argon 40, a noble gas. So mass number is the same. Atomic number goes from 19 to 18. 18 is the atomic number of argon, and that is the element now that we're looking at. So that's beta capture. Now, one of the activities is to work through these tables. And this table describes a decay chain, which is a series of decays that an atom can experience. Some atoms actually decay more than once before finally becoming a stable isotope. This atom that we start with, thorium-232, goes through these different decays until finally becoming a stable atom here. So what you'll do is at each step, you'll alter the atom based on the type of decay or capture. Let's do two together. Beta decay. So one neutron becomes a proton. So our atomic number goes up to 91. Now with beta decay, mass doesn't change, so we're still at 232. Now, atomic number 91 on our good friend, the periodic table, that's right here, protactinium. So Pa is our symbol, and protactinium is the element. So this atom of protactinium will then experience alpha decay. It will release one of these alpha particles. So we're losing 2 protons, so the atomic number goes down by 2. It's now 89. Our mass number decreases by 4 because we're losing 4 of these large particles from the nucleus. So 232 minus 4 is 228. Now again, looking at the periodic table, atomic number 89 is actinium, Ac. So now our atom is actinium. And this atom then will experience beta capture, alpha decay again, and beta decay. And at that point, it will become a stable isotope.